Hi, everyone. On behalf of the Southeast New England Program Network, welcome to our webinar titled Emerging Stormwater Technologies in Rhode Island, Oldcastle Infrastructure's NSBB, brought to you by the Stormwater Innovation Center. My name is Leah Soloway from the New England Environmental Finance Center, and I'll be managing logistics for today's program. Before we get started, I'd like to introduce and provide you all with a little background about the SNEP network. The SNEP network's mission is to empower communities to achieve healthy watersheds, sustainable financing, and long-term climate resilience through the management of stormwater and restoration projects. The SNEP network focuses on building local capacity by providing no-cost trainings, webinars, and technical assistance to communities in the SNEP region. If you would like to learn more, please visit our website, snepnetwork.org. And before we begin the webinar, there are a few logistics to keep in mind. First, everyone will be on mute to ensure audio quality. At the end of the webinar, there will be a Q&A session. You'll be able to ask questions by typing them into the Q&A box on your Zoom control panel. We look forward to answering questions, so please type them in at any time. We have closed captions available for today's webinar. To view the closed captions, please click on the closed captions icon in your Zoom control panel. And on that note, I'd like to hand things over to Rebecca Reeves, Education and Outreach Manager for the Stormwater Innovation Center. Thanks, Rebecca.
Thank you, Leah. Let's share my screen here. So before we begin, I'm Rebecca Reeves, Education Outreach Manager with the Stormwater Innovation Center. To provide a little bit of background on the Innovation Center as well, I thought I'd share a few slides. So we are an organization that's part of the Audubon Society of Rhode Island. However, we focus on stormwater initiatives. Much of our work is based in the urban core of Rhode Island and in Roger Williams Park in Providence. However, we do work all over the state. And our 4 pillars of our work are monitoring, training, community engagement, and collaboration. So just to give you a taste of some of the projects we do, these are some pictures from our projects. So upper left here, we have one of our partners at the Nature Conservancy monitoring for invasive carp in one of the water bodies within Roger Williams Park. This picture to the bottom right below it is a monitoring initiative we have called RainSnap, where we ask volunteers to monitor green infrastructure performance within Roger Williams Park. And then right next to that is at our Rain Harvest Festival, which is an art and music festival in the park where we highlight environmental topics. So we had an artist come in and create a mural at the inlet to one of the green infrastructure projects within the park. So we had some families touring that and doing a little scavenger hunt activity. Under that is some students that we worked with last year. We do stormwater programming in schools and teach students about water quality and also do an art project associated with that. So in this particular instance, we had students build pollinator boxes and paint them and then put little green roofs on top of them. So that was a fun project. We also do a lot of trainings for people in the field of green infrastructure and stormwater management. So to your upper right, you'll see a picture of one of our trainings. I think this one was at our recent Stormwater Expo in fall. If you'd like more information about what we do, stormwaterinnovation.org is our website. We also have social media. So without further ado, I'd like to introduce our presenters, and this presentation will be on Oldcastle Infrastructure's Nutrient Separating Baffle Box, or the NSBB, which is pictured to your right on this slide. Full presenter bios are available on our website, as will be a recording of this presentation if you missed it or would like to send it around. The link is right there on the slide. And slides will also be available to everyone who's attended after the presentation. So our presenters are Leah Soloway, who you just met with the SNEP network, Christopher Dill, who's with the Rhode Island Department of Environmental Management, Evan Selbigger with Oldcastle Infrastructure, and David Monjo with Oldcastle Infrastructure as well. So I will go ahead and turn it over to Chris Dill, who will be presenting on the permitting process for new stormwater technologies in Rhode Island.
All right, can you, let me switch this. Can everybody see that now?
We got it.
Awesome, thank you. Cool, so hello everyone. My name is Christopher Dill. I'm an environmental engineer with the Rhode Island Department of Environmental Management, and I work in the Stormwater Construction Permitting Program. And yeah, we're the folks that approve different stormwater proprietary technology devices for the state of Rhode Island. So that technology review committee is comprised of staff from Rhode Island DEM, DOT, and the CRMC, which is the Coastal Resources Management Council. From DEM, we have my supervisor, Nicholas Pisani, and myself. I'm the primary contact for this program. So if anyone has any questions about it, or if a vendor would like to apply to get their technology certified by Rhode Island, they would reach out to me and we would get the process rolling with that, which I will go over in just a minute. From DOT, we have Deirdre Pava, and CRMC, we have Ross Singer. So just a quick overview of the ways we can approve devices. Basically, there are 3 buckets that things can fall in. You start out with retrofit. That's pretty general. The requirements for that are pretty loose, and we're just looking to make an improvement on some older sites that could stand to benefit from some stormwater infrastructure. And a lot of these proprietary devices are great because they're typically more condensed, so they take up a lot less space for those more urban areas where it can be tough to get some treatment. Second bucket is pre-treatment, and we use this typically preceding a full water quality BMP, just to kind of condense the maintenance area for the bulk of it, and extend the life of the main BMP itself, and also cut costs and make maintenance a little easier. The main requirement for that is that it's got to remove at least 25% TSS. And the final bucket, which is the most strict and hardest to get certified for, it's for a water quality BMP. So that would be basically on par with like a sand filter or an infiltration basin. And to qualify for these, the device has to get 85% TSS removal, 60% pathogens, and then 30% for nitrogen and phosphorus. And vendors can also demonstrate that they might get some other pollutant removals such as metals or higher than our baseline standards. And the device that we're going over today, the NSBB, that is certified for pre-treatment and retrofits. And then also at the bottom of that slide, you can see the page with the application form for vendors that want to submit technology applications. And this is a flow chart of our process. Basically, the vendor, gets the tape or tarp testing, which I'll go over that in another minute. They get the testing for their device showing that it meets the pollutant removal criteria. They submit their application. The technology review committee reviews it, kind of evaluates it, and then typically we have some comments or questions that we'll go back with. And if the vendor can, satisfy our concerns or questions, then we certify the device and, work out the final conditions, like, things like sizing, maintenance, reporting, and whatnot. We issue the certification, which is valid for 5 years. And then we end up where we're at today, where we're now training people on it and trying to, get it out there so people can make use of these wonderful devices. Like I said, the tape and tarp programs, those at the bottom of the screen, you can see the acronym, what those stand for. So TAPE is a program through the state of Washington. They're basically the front runner for certifying these types of devices and verifying a very standardized protocol for testing. And then TARP, that program has since been dissolved, but typically we allow anyone that gets a New Jersey certification that typically qualifies for pre-treatment. And then if they don't have any, New Jersey or Washington certifications, they can submit third-party verified testing that has to basically be on par with tape requirements. And you can refer to those sections of the Rhode Island stormwater rules if you want to read up on that a little bit more. But typically reciprocity through those other programs is the fastest way and easiest to get a device certified. As I previously mentioned, the certifications are good for 5 years. So at the end of that 5 years, the vendor has to get it recertified, basically show us that it's still working, give us any new studies that they've completed. And, if they had previously received reciprocity, we'd like that their other certifications are still active if we're going to recertify. And yeah, this is a link to the list of the currently approved stormwater proprietary BMPs for Rhode Island. See if I can open that up really quick to show everybody. So this is what we're working with. You can see these are all the water quality BMPs that we have approved right there. And then it moves on to pre-treatment and retrofits. You can click on the hyperlinks for the device certification or O&M manual. There's all the models that they have, what they're rated for, and then contact information. So going back to the presentation, I don't know if everybody was actually able to see that or not, if it was just stuck on my PowerPoint, but if you didn't, just click on that link and you'll be able to check it out. And yeah, with that, if anybody has any questions for me, feel free to speak up now or at the end, or shoot me an email, give me a call, whatever works best for you. And with that, I will turn it over to Evan, who is going to be our presenter on the NSBB.
Well, good morning, everybody. Give me a second to get my screen loaded up here. Everybody, oh, hang on. Great, now it's not letting me click on those two option buttons. It's worked earlier. I'm assuming everybody can see my screen.
We cannot see it yet.
Oh, hold on. No, we don't.
All
We've
right.
got we've got your camera. That's it at the moment.
All right, it doesn't, the options, it won't let me click on those two buttons for the share the sound on the when we do the video. Don't know why.
Saying it's your screen is being shared now, Evan.
Okay, good. I mean,
So
we
we've
had
got the presentation up.
all right, well, good. Well, we're just gonna go through it. It did work before when we were testing it, but for some reason it doesn't want to let me click on those buttons now. Anyway, so my name is Evan Selbiger. I've been working for Oldcastle for 9 years. Some people consider me the NSBB product specialist, but my main role is inside sales. With that, I'm going to jump right into this and get started. So the objective of this webinar is so that you can learn everything that you need to know about what the NSBB is and what it does. We're going to go over sizing, how to use them, and then the key message is going to be about maintenance. So the NSBB is just one of the offerings that Oldcastle offers in our total stormwater management portfolio. It is a pre-treatment device. It can be pre-treatment for underground storage, above ground ponds. it can be used, again, for pre-treatment going out to impaired water bodies. It is a hydrodynamic separator, and it's also California trash capture compliant. I know we're not in California, but I just thought I'd mention it. So the NSBB, or again, the nutrient separating baffle box, is a pre-treatment system to remove TSS, growth solids, trash, and debris. One of the unique features of the NSBB is our centralized screen system, which sits above the static water level when the rain stops. So that allows everything else in there to dry out between rain events. Installation is easy for the contractors. Everything is pre-installed inside the concrete vault. It's a two-part system, so you have a base and you have a top section. And so it makes it easy for the contractors. It is retrofittable, as Chris had talked about earlier, to existing watersheds, and obviously it can be done in new construction as well. It's inline, so there's no need for external bypass. All the internal bypass happens inside the system. And it is a high peak flow capacity, or it has a high peak flow capacity. We do have major approvals. We did just pass the new NJCAT, NJDEP certification and verification beginning of this year, 2025. We also have the Washington Department of Ecology, and again, the California Water Board approvals. And I don't think anybody's going to be able to hear the sound on this, but I'm going to play it and I'm going to talk through it. So you can still hear me, I'm assuming, Dave, correct?
That is correct. And the video is playing as well.
I do apologize if nobody could hear the sound. I don't know if anybody could hear me talking. But let's just go over some of the things you saw on the video. We'll go over the parts real quick. Again, you have two components, bottom half and the top half. You have access covers. These can be cast iron rings and covers, or hatches, depending on the location. You have a centralized screen system. You have turbulence deflectors, and you have a floating skimmer. And that's important because as the water flow increases inside the baffle box, once the flow rate reaches at least 4 CFS, then the skimmer will start to float, which allows uninterrupted the water to pass underneath it. The screen system is centrally located. You have bypass along the sides as well as over the top of the system if necessary. The skimmer can rise all the way to the top of the vault, thereby preventing anything that floats from getting past. And again, here's a little bit a better look at it. You've got your standard 3/4 inch expanded metal. That is what comes standard. And in California, the trash capture 5mm perforated stainless steel screen is what's required. The lids are what we call the sun guide lids. They have a latch in the center and they slide open. They don't hinge, they slide open. You do have bottom doors that hinge open, which allows you to access the sumps for cleanouts. Nobody has to enter the vault in order to clean it out. Everything can be done from the surface. Here's a little bit better picture of what the floating skimmer looks like and how the water goes, again, around the sides underneath the skimmer. And again, this because the skimmer floats and doesn't act like a fixed concrete weir, it does reduce the amount of head loss that is possible. The Rhode molded floats, it's made out of plastic. You've got fiberglass body. This orange edge over here is a geotextile fabric that sits in front of the track that therefore prevents small particles from getting in there and possibly getting the skimmer stuck. There's no mechanical moving parts. The wheels are made out of Delrin, which is a plastic. So your standard vault sizes are 4x8, 5x10, 6x12, and 8x16. These are internal measurements. There are other sizes available. We use these sizes because they utilize standard forms, which makes construction that much easier at the precast level. There are other special sizes, a 10x20 and a 12x24. Those are segmented boxes. In other words, they're put together in several pieces, the bottom and the top. You have a straight in, straight out pipe orientation on these boxes. However, the NSBB is capable of multiple pipe entries. In other words, you can have 4 entries into the nutrient separating baffle box. Straight in from the front, 2 each from either side, as long as it's in the first chamber, and then you can actually have a graded inlet over the top of the first chamber. So again, your plant is going to assemble all of your parts and pieces in the bottom half, including the screen system. The top half will have the tracks and the skimmer already installed, so that when it gets to the job site, all the contractor is going to have to do is install the base, install the top, connect the pipes. So again, the contractor is going to verify elevations, and they will install the inflow and outflow pipes. Inspection and maintenance. Again, in maintenance can be done, as you can see in this bottom right picture, is all done from the surface. No one has to enter the structure in order to clean it out. The top doors slide open so that the vac can vacuum out everything that's inside of the screen system. Here's a picture. You can see the top doors are slid open. There's a lot of leaves in here, and I'm sure up through New England during the fall is a heavy leaf dumping time. And after rain events, the NSBB will collect a lot of leaves. So again, no special tools or equipment is needed in order to clean it out. So when you're designing your system, some of the things that you need to know that are going to help us let you know what size structure you're going to need. So whatever regulatory requirements, the treatment flow rate is very important. We also want to know what the peak flow capacity is. We want to know what the pipe size is, and if the pipes are coming in or straight out, and at what angle if they're not perpendicular to the box. This is just a summary of the newest NJDEP numbers for your sizes and your treatment flow rate to meet that 50% TSS removal rate. And again, this is just a little bit more information that all was derived from the testing. Here's an example of a generic drawing of a 6-foot by 12-foot NSBB. And you can see that the screen system sits above, because your static water line is going to be at the invert of the pipe, of the lowest pipe, whether it's the inflow pipe or the outflow pipe, which can be at the same elevation, or the outflow pipe can be at a slightly lower elevation. That's fine. So that's where your static water level is going to sit, and that's going to be below the screen system. So the screen system will sit outside of the static water. So everything that gets captured is allowed to dry out between rain events. You've got your manhole access points. You've got your sumps. This is, a head loss calculator that our solutions engineers will help us to figure out what size NSBB you will need. And all this stuff is inputted by them, and it comes out, it will tell us what size. In this particular case, it shows that 4 by 8. So when we're looking at an example of a project, you're going to see where the circle is here, where the NSBB is located on the project. You'll have your pipe dimensions, and you'll be able to see that it's going straight in, straight out. And of course, you have your rim and pipe invert elevations. So this is, again, just the review checklist that we perform. And again, we're using model 612, 6 by 12 on this particular project. So in New England, we have 9 baffle boxes in and around the city of Portland, Maine. This is just one of them. It's on State Street. And I can make these case studies available if anybody wants them. And then also we have one at Woodford Street. A couple of different examples. You can see how you've got some risers for the castings above ground. The baffle boxes can be put in a roadway. You need a minimum of 12 inches above the top of the vault to finish grade in order to have enough soil, rock, and pavement to put up there. So a couple of key messages: performance, support, we can bundle products, and maintenance. So performance, the NSBB is the industry-leading performance of a hydrodynamic separator baffle box system. There are other baffle boxes out there. The NSBB is the oldest and, again, the leading performer in this. And it is the original trash capture baffle box. It does have, the unique thing is the floating skimmer, which again minimizes head loss and allows for internal bypass. So you do have bypass along the sides as well as over the top of the screen system if necessary. And there's enough internal bypass that meets or exceeds the surface area of the incoming pipe. You do have a high debris capacity with the storage in the screen system, and the deflectors avoid resuspension and scour. As with any treatment system, you do have to maintain it. The NSBB works, so it does require maintenance. We do recommend a minimum of quarterly maintenance. And again, everything is done from finished grade. Everything is easily removed from the screen system without the need for dewatering the unit. Again, there's no entry required into the baffle box for maintenance. When we talk about bundling products, it helps create a stronger specified position, whether you're doing, again, the NSBB is part of pre-treatment to a pond to post-treatment, your complete treatment train approach. And Oldcastle does provide, it can provide this treatment train approach. We do have a full drainage and stormwater product offering giving us the ability to offer specifying engineers and contractors full site solutions. And in support, Oldcastle infrastructure is backed by a CRH company. We have vertical integration from product design through manufacturing, offers unmatched control. You're dealing with one company throughout the entire process. Again, we offer best-in-class support through dedicated stormwater sales, engineering, regulatory teams to ensure the best outcome to meet your project needs. And with that, I'll ask and see if there's any questions.
I do have one question here, Evan. Craig asks, what is the maximum allowable slope for existing pipe in and out of the box?
That's a good question. It varies. It also will vary from the distance, but I'm usually thinking around, I think in 15-degree slope is what I was told. I'm not going to, don't take that for 100% fact. That's something we would ask our solutions engineers about, because each structure will determine the slope that it can handle based on the size of the pipe and the size of the structure.
Yeah, I would agree. Certainly, in addition to slope, what we take into consideration is, the resulting capacity of that pipe and how it might relate to the peak flow that a particular device size can handle. To be sure that, that slope or that resulting flow would not be bigger than what the device itself is capable of handling.
Correct. And before somebody were to ask, yes, you can have pipes come in at an angle to the, besides a downward angle or downward slope, you can have pipes entering the box at angles, but those angles have to be less than 30 degrees.
I have another question. If the trash box is full, say in the fall or after a storm, does this reduce the flow capacity?
No, because even if the screen system is 100% impacted, it can't handle any more, water will still flow through the baffle box because you have built-in bypass along the sides and over the top if necessary. And again, the floating skimmer, which is a key component to the nutrient separating baffle box, allows for helps reduce head loss by flowing as it lifts during a high flow event to allow water to flow out underneath.
Another question from Eric. In a site with issues which would restrict the vault total depth, what would be the minimum depth of the vault below the pipe invert? Say for a 15-inch pipe.
The typical baffle box has a standard sump size. Those, depending on jurisdiction and regulatory requirements, can be reduced. The 4x8, which is the smallest baffle box, I believe, has a 3-foot sump. The sumps can be reduced again if it's not, again, if it was an NJCAT required regulatory requirement, you would not. However, you can have negative pipe inverts, especially along coastal applications. We've done numerous installations along the coast of Florida, both east and west coast, where vaults had the negative pipe inverts.
Yeah, and I'll add, in my experience with separator systems in general, we always have to take into consideration the volume that's needed for so that it can provide performance, its treatment. And then there is a portion of the sump that's always devoted to storage. And it's a common question, can we make it shorter? The long and short of it is the trade-off is you may, in those circumstances, decrease the volume that you now have to store sediments. So we wouldn't want to encroach on the performance capacity of the device, but as it gets shorter, again, we could lose some storage capacity.
That's true, Dave, and it does then would require more frequent maintenance as far as cleaning out the sump.
Correct. Ian asks a question. What is the recommendation for cleaning sediment in the sumps below the rack? How do you open the bottom doors?
All right, the bottom doors. So first you would open the top doors to the main part of the screen system by sliding them open. The bottom doors have hooks on them. You are provided a tool, it's basically a hook on a Mr. Longarm's telescoping pole. You were able to open up those doors by lifting them. They lean up against the inside of the screen system so that you can access the middle chamber. The first chamber has a door on the lead-in, and that lead-in can also be lifted up using that same tool, and it leans up against the inflow pipe so it stays open. It's recommended, and again, depends on the jurisdiction, but at a minimum, you'd want to clean out the sediment when it reaches half the depth of the sump. But even if that sump were to be completely full, and the second sump were to be completely full, and the screen system were to be completely full, water will still flow through the baffle box, again, because you have bypass along the sides and over the top of the screen system.
Another question. Would you please explain the benefits of minimized head loss provided by the floating skimmer?
So with the skimmer producing less head loss, so think about if this was a fixed concrete weir, you'd have, and it was 2 feet tall. The water wasn't going underneath it. It only goes over the top of it. So that creates 2 feet of head loss upstream. By utilizing a floating skimmer device, such as we do, as the flow rate increases, the skimmer rises to allow water to flow out underneath, thereby reducing head loss and preventing any flooding upstream.
Yeah, this is an important point, and admittedly, it's often ignored or not entirely addressed. As most people can appreciate, devices such as the NSBB and other separators, they're really sized primarily to treat a water quality volume, but the device still has to at least be able to hydraulically pass water in big storm events. And when you see those larger flow events, there's always concern about upstream impacts of water levels. So that's really where that comes into play, is trying to not create a high water level situation upstream. Another question from Brian, and this one I know you talked about in the video and perhaps even in a subsequent question, but it's probably worth highlighting again. How is sediment cleaned out of the system, and what is the procedure?
Well, again, we talked about that a little bit, but basically your service and maintenance division of the city, or you hire an outside contractor with a vac truck. You'd remove the rings and covers, you'd look inside. The first thing you're going to do is open up the top doors to the basket system. You're going to vacuum out what's in there. And then if it's determined that there's enough sediment inside the sumps, you're going to lift up the bottom doors. In other words, the front door on the lead-in, and then the bottom door is inside the screen system. And then the vac line will be able to go all the way to the bottom and then vacuum out the sediment that's in the bottom of the sumps.
Here's a really good question, and a pretty common one from Cynthia. Could the NSBB address fertilizer, rolled salt, and bacterial storm drain effluent? Yeah, I'll leave it at that. She expands a little bit on the application or the installation location, but can it address fertilizer, road salt, and bacterial storm drain effluent?
It's going to remove all of those things depending on what it's attached to. Road salt is a difficult one because it's typically in solution a lot of times. And if salt is a concern, whether it's from road salt or it's from a coastal application, the entire screen system can be made out of stainless steel, thereby reducing any dissimilar metals issues going on there. But again, it can remove things as long as it's attached to something else. So fertilizer, if it's again in solution, probably is not going to be removed, but if it's attached to natural materials, leaves, grass, clippings, all that kind of stuff, then it will get removed by the fact that it's being captured in the screen system.
Yeah, I'll expand on this a little bit too, Evan. So,
Sure.
because as I said, in the intro to the question, this is a common question that comes up with a lot of different treatment devices. Road salt is one of the most complicated things to deal with because as Evan was explaining, it's by and large completely soluble in water. It might exist in different states depending on residence time and so on, but typically you can assume it's soluble in water. And there really are no proprietary devices designed specifically to remove road salt. It's not a common pollutant to be treated. And again, as he mentioned with fertilizer, it's what we often refer to as nutrients. They can exist in different states. It's not uncommon to find that chemically they will attach to larger debris, which is what Evan was referring to, and therefore be removed as that other debris or sediment is removed. The soluble component of fertilizer is difficult to remove in a system like this, but this is when we see devices such as filter systems used. And Chris, in his earlier introduction, talking about the various types of devices that are approved for use in the state of Rhode Island, oftentimes for full treatment, pardon me, what you see used there are filtration devices that actually use a media or a cartridge of some type. And they do a much better job of reducing or removing nutrients than a separation type device. So there are devices that can work well at addressing fertilizer, and NSBB can help. It may not be the ideal solution. I think it's probably the best way to answer that.
And I would add that we talked a little bit about a complete treatment train approach, and that would be combining multiple products to produce a final result.
Yeah, very true. Okay, more questions. Tara asks, locally, I see towns requiring 50 to 60% total phosphorus removal. Do you have a series of devices that would pair with this pre-treatment device to meet higher requirements? So that was a really good segue right there. Playing off my earlier answer and even what Evan said, typically you're looking at filtration type devices to get phosphorus removal up into this range. And yes, sometimes we do see, different types of devices used in combination with each other in series. So it depends on the application, certainly, where it might make sense to do that. But it's not unheard of, that's for sure. At times, a filter device may be used by itself. But hopefully that answers your question. Moving on.
Keep going.
Stephanie asks, can maintenance be done with hand tools on smaller systems? What happens if that hook tool is lost or misplaced? Can another tool be used for maintenance access? Is there any risk of damage to any of the inner components? And if so, what is the replacement procedure? So sort of a three-part question, but one is about the access tool, and then two might be, considerations for replacing equipment.
Well, again, the tools are provided with the baffle box. If they're lost, replacements can be ordered. Again, it's not necessary for someone to go into the vault in order to clean it out. So could you use hand tools if you actually had to? Sure, but again, you don't necessarily want to have people go inside the vault at any time because then that becomes a confined space entry, and that requires more specialized equipment and personnel. And again, as far as if anything were to get damaged, I mean, perfect example, just dealing with this as of right now, we have a very large baffle box in the city of Dubuque, Iowa. And we're going to be working to replace the top doors and tracks for that system, because middle of last year, they had a very, very large rain event, and something large came in and actually caused the top doors, the front track to break, and it also got stuck underneath. So if something like that were to happen, again, a natural occurrence, we do have a service and maintenance department that would assess the damage and recommend replacements and how to do it.
Okay. And we've got a follow-up from Cynthia. Now, Cynthia earlier asked the question about fertilizer and road salt.
Okay.
In this case, with a 2-foot wide pipe, is anything else available in our case? And she makes a reference to DEM. So I think what she is asking is, obviously Rhode Island DEM, as Chris mentioned earlier, evaluates different types of technologies. Probably the simple here in the context of this webinar is that the link that Chris had in his portion of the presentation that brings you to the list of approved practices in the state of Rhode Island would give you some options there. Because again, if we're looking at fertilizer, the likelihood is you might be looking at a filter that would be required. So I think as a starting point, that would be the best place to look at options.
Yeah, so Cynthia, my contact information, we shared it earlier, and that'll also be available on the recording. And I think Leah and Rebecca are also going to send out the recording and all of our slides and all that. So if you want to just shoot me an email, we can discuss this afterwards. So just so I can get a little bit more details on what exactly you're looking for.
One more question, maybe the last. We'll see. Keep them rolling if you want.
Go for it.
Sorry if I missed cost range examples. So thoughts on range of cost, Evan?
Well, cost for the typical unit can range from, again, the small size, probably the price of the unit itself. Installation, obviously, by the contractor is area based, but depending on the area of the country, prices vary. But I would say from anywhere from 20,000 into up to over 150,000. It really depends on the size of the structure, where it's located, how many pipes coming in, and again, the price varies from region to region across the United States.
Yeah, one of the reasons, a big reason that costs vary across the country is simply because precast costs vary from region to region in the country, widely vary depending on where you're located. So it's hard to have a single price in countrywide. Okay. At this point, I think looks like all the questions have been answered. Yeah.
Okay, well, thank you to all of our presenters for your expertise and your time. As mentioned, we will make all the slides available to everyone who attended, as well as the video that will be embedded in the slides. It was in the chat. We'll put a link to it on our website, stormwaterinnovation.org, and the recording of the presentation will also be available there. But look out for an email from Leah on all of those materials as well. So thank you all for attending. Thank you to our presenters, and I hope you all have a wonderful rest of your day.
Thank you, everybody.